So today we're going to be talking about finding the equation of a line from a graph. So over here on the left, I have drawn a graph and I've drawn a line and I've highlighted two separate points on that line. So we have the point 1, 1 and the point 6, 6. So those are two different points we're going to be using to find the equation. So the first step to finding the equation is finding the slope. So the common formula for the slope is basically y2 minus y1 over x2 minus x1. So to figure out which values are y1, which one's y2, and so on and so forth, we're basically going to write down our 2 points. So we have the point 1, 1 and 6, 6. So these are the 2 points we have from our graph. So if your graph doesn't point out those two specific coordinates like that I have, then you're probably going to want to figure it out using the grid lines and figure out 2 points and write them down. You're always going to need 2 points, 2 separate points to find the slope. So we're going to label this as our first coordinate and this is our second coordinate. So from our first coordinate, we have that x is equal to 1 and that y is equal to 1. Because x is equal to 1 and y is equal to 1 from our coordinate. Because coordinates are always in the form of x, y. So the first term will be x and the second term will be y. So for our second term, our x is defined as 6 and our y is also defined as 6. And now what we're going to do is we're going to apply subscripts to them essentially. So we know that x is equal to 1. But so we're going to write it as x to the base 1 is equal to 1. Now what does this 1 mean? It's basically the x applied to the first coordinate. So the x of the first coordinate is equal to 1, and then also the y of the first coordinate is equal to 1. So, and then we're also going to do it for the second coordinate. So from here, we know that x is equal to 6. So the x value of the second coordinate is equal to 6. And the same here is the y value of the second coordinate is equal to 6. Now there's two things to note here. You can apply any set of points as your first or second. So we could essentially make 1, 1 as our second coordinate and also make 6, 6 as our first coordinate. It doesn't really matter how you do that. But if you assign 6, 6 as your second coordinate, as I have done here, you're going to need both of your subscripts to be the same. So subscript is just the number at the bottom, so like the base, like here we have 1, here we have 1, here we have 2, and here we have 2. So if this is your second, so if this essentially is your second coordinate, then your base has to be the same. It has to be 2 for both your x and your y. Now the same thing goes for here. We've applied that this is our first coordinate. So 1, 1 is our first coordinate. So that means that the bases we apply to the x term and the y term are both going to be 1. So you can't make x1 is equal to 1 and you can't change this as y2 is equal to 1. It can't be like that. So basically, to summarize what I just said, when you apply, so you have two different coordinates. One of them will be your first one like this one and one of them will be your second one like this one. And from your first one, you're just going to find the x and y value and write them as a base of like 1 over here. And then for your second one, you're going to write them as a base of 2. Hopefully that makes sense. So now we're going to find the slope and we're just basically going to substitute everything back into our equation. We figured out from all of this information that x1 is equal to 1, as you can see here. y1 is equal to 1, as you can see here. x2 is equal to 6, as you can see here, and y2 is equal to 6, as you can see here. So now we're going to use these sets of information and plug them back into our original equation for the slope. Okay, now since we have all of our information, we're going to put everything back into our original equation. So our original equation we need, so slope is equal to, we're going to do y2, so y2 from this equation is equal to 6 minus y1, and from here we found that y1 is equal to 1, and we're going to divide everything by x2, which we found as 6 as that again, and also x1, which is we found as 1, so minus 1. And if you simplify that, you'll get 6 minus 1 is 5, 6 minus 1 is 5, and you simplify that, you get 1. So your slope is all in all equal to 1. Okay, so now that we found the slope, which is 1, and I've written that over here on the left, we're going to want to find the y-intercept. That's the second part of our finding the equation. That's the second thing we have to do. So from the graph, normally you can find the y-intercept from the graph. So basically from the graph, you can normally see the y-intercept. I will show you in the next example if you can't see the y-intercept in the graph, but for now, so the y-intercept is essentially where the line crosses the y-axis. And that's the whole idea of a y-intercept. So if you think about it, an intercept is basically where it intercepts the y-axis. So it's pretty simple. If we look at our graph, we can see, so this would be the y-axis up here. So like this whole thing down there is our y-intercept. And there's really only, so like let's go all the way from the top and go all the way to the bottom. There's really only one point where it crosses the y-intercept, and there's always only going to be one point where it crosses the y-intercept if it's a function graph. And if it's a line graph, similar to what we have here. So there's one point, and it's the origin, and the origin always has the coordinates of 0, 0. So basically our y-intercept is equal to 0 because it just crosses at 0. So all we have to do is just note that down. So our y-intercept is equal to 0. So now that we have our y-intercept and our slope, we're going to want to put everything together and form our equation. Okay, so now your third step is to basically just write the equation of a line. So from what we've done previously, we know that our slope is equal to 1 and our y-intercept is equal to 0. And those are only the two pieces of information you need to know if you have a graph similar to the one on the left. So the basic form of a line graph, or like the equation for a line graph, is y equals mx plus b. Now it does seem a bit confusing right now, but from this equation, essentially, all we need to find is the value of m and the value of b. Because if you think about it, all line equations are like y equals x plus 3 or y equals 2x plus 1. And you can see that they always have a y term and always have an x term. So basically from our equation, we're going to figure out the value of m and the value of b. So m will always be your slope. The slope of your graph is the value of m. So it's your slope of your graph. And b will always be your y-intercept. Now you can see why we figured the slope and y-intercept is because we want to be able to substitute it back into this equation. So the equation is y equals mx plus b. From this information, we know that our slope is equal to 1, which therefore means that m is equal to 1 because m is basically the slope of the graph. So for m, we can substitute 1. And from the same piece of information we have here, we know that the y-intercept, so the y-intercept is equal to 0, therefore making b equal to 0 because b is essentially your y-intercept. So we also know that b is equal to 0. So now let's simplify this equation. So from that, we're going to write y equals 1x plus 0. Now normally when you have a 1 in front of the x, you can just omit it and it still means the same thing. And when you have a 0, you really don't need to add that. So let's clean that up and let's write a neater equation. The neater equation would be y equals x. Okay, so for our second example, as you can see, I have a graph on the left, but the one thing different between this graph and the previous graph we saw was that you can't really see where it intercepts the y-axis. So like there's no point where the line basically crosses the y-axis. There is, because the line will it'll basically just extend and extend and extend and technically still meet that y-axis somewhere. But we can't see it right now because our graph is like cut off. So basically we're going to do the same thing as before, except there's another step in finding the y-intercept that I'm going to teach you once we get there. So first off, let's find the slope. As I said before, the formula for the slope is y2 minus y1 over x2 minus x1. And I've pointed out two coordinates in this graph as well. So our two coordinates are 3, 1 and 4, 6. So we're going to assign this to be our second coordinate and this to be our first coordinate. Let's just do that for fun this time. So if this is our second coordinate, from our second coordinate we know x is equal to 3 and y is equal to 1. And in our first coordinate, x is equal to 4 and y is equal to 6. So let's assign our final values. Since this is our second coordinate, we're going to do x2 is equal to 3 and y2 is equal to 1. These both belong to the second coordinate, which is why we have that 2 over here. And we're going to assign, so for this one, they both belong to the first coordinate. So we're going to assign x1 is equal to 4 and y1 is equal to 6. So now that we've set our sort of kind of table of values, we're going to substitute everything back into this equation. So slope is equal to y2 minus y1 over x2 minus x1, and we're going to substitute everything. So slope is equal to y2, in this case y2 is equal to 1, so 1 minus y1, which is equal to 6, over x2, and x2 is equal to 3, so 3 minus x1 is equal to 4, so 3 minus 4. Now if you simplify this, you're going to get that the slope is equal to negative 5 over negative 1. And if you simplify that even further, you'll get that negative 5 over negative 1 is just positive 5. So we figured out that the slope of our equation is 5. Okay, so from our previous steps, we figured out that the slope of the equation is equal to 5. And now we have to figure out the y-intercept. Now, the y-intercept, clearly you cannot see it from the graph, as I said before. So what we're going to do now is basically just substitute our slope into the equation of a line, which is mx plus b. And slope is equal to m, so we'll write that as y equals 5x plus b. And we still don't know b. So we still don't know b because b is the y-intercept and we clearly can't see that from the graph. So to figure out b, we're going to take a random point from our graph over here and substitute it for x and y. So for y and x, we're going to substitute. So I have pointed out 2 points. We have 3, 1 and 4, 6. Just for simplicity, we're going to go with this one. So 3, 1. And in the point 3, 1, x is equal to 3 and y is equal to 1. So instead of y, we're going to substitute 1. And next to 5, we're going to substitute 3. And then we're still going to leave our b. So now it's pretty much just solving. We're just going to solve for b. So 1 is equal to 15 plus b. And if you subtract 15 from both sides, you'll get that negative 14 is equal to b. So as you can see, we've kind of figured out what b is just using the slope and the basic equation of a line, which is y equals mx plus b. So now let's substitute that back into our line and we have our final answer. So we figured out our y-intercept, and our y-intercept is basically the value of b that we just found out, and we're going to substitute everything now. So we know that the equation of a line is y equals mx plus b. We know that m is equal to 5, and b is equal to negative 14, so we're going to do minus 14. So the equation of this graph on the left over here is y equals 5x minus 14.